Okay, in today's lesson, we are going to look at more examples of using the strategy of shifting the shaded parts in a composite figure to form a shape that you're more familiar with. And if you are able to find the area of that shape, you will also be able to find the area of the shaded parts. Okay. The first example we have is here. In this example, we have a figure that is made up of 3 identical circles. A, B, and C are the centers of the circles, and each circle has a radius of 7 centimeters. Okay. In this question, we have to find the total area of the 3 shaded parts here. Okay, let us see how we are going to work out this problem. The radius of each circle is 7 centimeters, so let me indicate down in the figure. So this is 7 centimeters each. Okay, then we take a look at this triangle ABC. What can you tell me about this triangle ABC? Right, you'll notice that in this triangle, the length of AB is equal to the length of BC equal to the length of CA. Alright, and each side of the triangle is 14 centimeters. So in other words, this is actually an equilateral triangle. So if this is an equilateral triangle, that means the angle here is 60 degrees, the angle here is 60 degrees, and the angle here is 60 degrees. So what I'm going to do now is I'm going to shift the 2 shaded part here and place it here. Okay, and I'm going to do the same for this shaded part here. I'm going to place it here. So you have noticed that the 3 shaded parts actually form a semicircle. Alright, each angle here is 60 degrees. So if we combine all these 3 angles together, we actually get 180 degrees. Okay, a full circle is 360 degrees. So if this is 180 degrees, this actually forms a semicircle. So to find the area of the 3 shaded parts, it's the same as finding the area of this semicircle. So I can write area of shaded parts is the same as the area of a semicircle. So if it's the area of a semicircle, then it will be half multiplied by pi multiplied by radius multiplied by radius. And that will give us, pi is given as 327, radius is 7 centimeters. Okay, if we simplify the fractions here, the area of the semicircle is 77 square centimeter. So in other words, the area of the 3 shaded parts is also 77 square centimeters. Let us look at another example. In this example, we have PQRS, which is a square of side 20 centimeters. Then we have another circle within this square, circle TUVW. The circumference of this circle just touches the edges of the square at point T, U, V, and W. That means the diameter of the square is same as the diameter of the circle TUBW is the same as the side of the square. So it will be 20 centimeters. We also have another semicircle here, POS, another semicircle here, QOR. So this big circle here together with the other two semicircles, they all share the same radii. So we can also conclude that the radius of the semicircle is actually 10 centimeters, since 20 centimeters is the diameter of the circle TUBW. So let us indicate this down first. Okay, in this question, we have to find the area of the shaded parts. So like the previous example, we are going to use the strategy of shifting the shaded parts into a shape that we are familiar with. So first, let me shift this shaded part down. Okay, and shift it to here. Okay, next we're going to shift this shaded part here and then place it there. So what will you have noticed? Right, you will have noticed that by shifting these two shaded parts down to here, the total area of the shaded part is actually consists of this area here. So to find this area, this shaded part here, is very simple. All we need to do is take the area of this rectangle and take away the area of the semicircle here. Okay, so let me draw a line there so that you can see the rectangle more clearly. Okay, so we are going to take the area of rectangle UQRW, and then we're going to take away the area of this semicircle, and the remaining area will be the area of the shaded parts that we need to find. Okay, so let us find rectangle UQRW first. Okay, so the length of the rectangle is 20. The breadth of the rectangle is this part, which is actually the radius of the semicircle, which works out to be 10 centimeters. So the area of the rectangle is 20 square centimeters. Next, we are going to find the area of the semicircle. So semicircle KUBW. So the formula for finding the area of a semicircle is half multiplied by pi multiplied by radius multiplied by radius. Okay, pi is taken as 3.14 and the radius is 10 centimeters. So this is 157 square centimeter. Okay, sorry about the mistake here. There's actually 200 square centimeter and not 20 square centimeter. Right? So area of rectangle is 200 square centimeters. Okay, what we're going to do next is we're going to find the shaded parts. So we are going to subtract the semicircle, the area of the semicircle from the area of the rectangle. So we take 200, take away 157. Okay, and that will give us 43 square centimeter. So the area of the shaded parts is 43 square centimeters. Okay, so let me repeat what we did just now. The original shaded part was here. Okay, so the original shaded parts was separated like this. Okay, so to find the total area of the shaded parts, we apply the strategy of shifting the shaded parts here, and we did the same for this part here, such that when the shaded parts are combined together, you can easily see that the total area of this shaded part is obtained by subtracting the area of the semicircle from the area of the rectangle. So this is an easier method to find the area of the shaded parts.